Hi there, this is Jacob Nash, Algebra Lessons, and this is Unit 7, Lesson 2, on knowing if the inverse is a function, if the inverse of a function is also a function. That's what I'm trying to say. So, how do we know? We know that when they can be inverse relations by the last lesson, but now we need to see, are they both functions? Well, obviously, the first one's a function because, you wouldn't be given that if it wasn't a function, so, sorry. Graph both. That's what you need to do. And if the original fails the horizontal line test, which we'll review what that is, I've said that before, but, or the inverse fails the vertical line test, then their inverse is not a function. It doesn't matter if the original fails the horizontal line test. Basically, if something fails the vertical line test, it's not a function. If something fails the horizontal line test, it is a function, but its inverse is not a function. So we could look at it either way. We could just see if the f of x fails the horizontal line test, and then we would know that the inverse wouldn't pass the vertical line test, meaning it's not a function. Or we could just graph both. But we'll just see how that is. So, to review what that is, the horizontal line test and vertical line test just means that you draw either a horizontal or vertical line, and if whatever thing you draw, whatever line you happen to graph or function you happen to graph, if it passes through the line 2 times, then that means it's not a function 2 or more times. So here's a horizontal line test. So let's have this horizontal line, and if we had a graph like this, then it passes it because it only goes through once. But if it's something like this, then it fails it. So in other words, something that looks like a quadratic means that its inverse wouldn't be a function, because we always know that it would fail the horizontal line test, meaning that the inverse would fail the vertical line test. So that's the horizontal line test. Let's see the vertical. So, same thing. One like this would pass it, but one like this wouldn't. And that's what your square root function kind of looks like if it had a reflected inverse on the, or not an inverse, but if it had, we'll see an example of what it looks like in a minute. But okay, so we have this one, all right? We have f of x. Let's graph that, and then we'll see if the other thing is a function. So let's see. So it's a line. So that means we can just use our y equals mxb rule. We know y-intercept is 5. Slope is 2, so up 2 over 1. Then you have your line. Okay, so that's our line. Well, that's pretty good. So let's see. If we have a vertical line or horizontal line at any given place, doesn't matter where it is, anywhere, does it pass it or fail it? It passes it. So we know the inverse is going to be a function. It will pass the vertical line test. But just in case, let's draw it. Well, actually, we need to find it first, because it wasn't given to us. So that's a review from the last lesson. Switch x and y. So we have 2y plus 5. And you would get, just skipping ahead, you would get, or sorry, what? Minus 5. Yeah, that's just not a good idea for me to just skip ahead like that. I would mess up. So 1/2 x minus 5/2. There. So we have a y-intercept this time at 2.5, negative 2.5, and we have a slope of 1/2. Oh, this thing's so annoying sometimes. 1/2, so kind of hard to draw because in between the lines. Alright, so there we go. We already knew that this is a function just because the green one passed the horizontal line test. But just to make sure, let's give this one the vertical line test and see. So, vertical line test, is there any point at which it touches 2 times? No. So, we would say that the inverse function of fx is a function, so we'll just say check. Alright, let's look at a different example. Alright, we're going to graph the inverse function of x squared minus 4. So this is a quadratic. We can see that it has a y-intercept of -4. Oh. Dang it, this stupid thing. So -4. 1, 2, 3, 4. Okay, zeros. If you were to factor this out by difference of squares, we would know that it is negative and positive 2. You could also just set that equal to 0 in this case. And then we can't see much just by doing that, but we at least know it would look something like this. Does this pass the horizontal line test? That tells us if its inverse would be a function. It does not. And I already said that earlier. A quadratic will never have an inverse that is a function, but just to see, let's graph this, which we first need to find what it is by switching x and y. So we have this. Then we have y squared equals x plus 4. X plus 4. Take the square root. And when you take the square root, remember you get a positive and a negative root x plus 4. So we just had our radical unit, so we know that this is going to be left 4. And then, since there's a negative and positive, one will reflect over the x-axis, the other will just be normal. So left 4, we know that. All right, let's go back here, plot that. Okay, so we have -4 square root function, so we know that it's going to we don't necessarily need to plot the points for this purpose, but we know that it would look something along the lines for that. And because it was plus and minus, also there will be one that reflects on the x-axis. And we can see that this fails the horizontal line test. Well, I mean, this fails the vertical line test. So it is not a function. No, it's not. So that's how you know if something is a function or not, an inverse. Basically, if the original fails the horizontal line test, it's not a function. But in case you didn't remember that, then if the inverse fails the vertical line test, not a function. So that's it for this video, and I'll see you on the next one.